In probability chapter, we have learned various theorem of the probability. Bernoulli theorem is one of them. In our last two video, we have done a detailed study of the Bernoulli theorem. In today's video also, we will do some more question which is related with the Bernoulli theorem and very important as examination point of view. I have written a questions on your blackboard. Three groups of children contains one boy, three girls, two boy, two girls, and three boy, one girls each other. It means the three groups of children. The first group have one boy and three girls. The second group have two boy and two girls, and third group have three boy and one girl. This question so many times repeated. Prove that the probability that the three selected contain one girls and two boys 13 upon 32. 13 upon 32. Among these, if one girl and two boys is selected, so prove that the probability will be 13 upon 32. Againly I am repeating the questions. Three group of children contains one boy, three girls, two boy, two girls, and three boy, one girls is over there. Now, one children selected from each of the group. Find the probability that two boy and one girl. The probability will be 13 upon 32. So we are to selected two boy, one girl. So it may be possible boy in first group, boy in second group, and girl in third group. It may be also possible boy in first group, girl in second group, and againly boy in third group. Or, so whenever or is over there, we have to use the plus. Already we have that. When or is over there, we have to use plus. Union is over there, we have to use plus. Already we have learned this. So among three group, from first group, A group boy, B group boy, C group girls. Boy, girl, boy, and it may be also possible girl, boy, boy. All three possibilities over there, nothing more possibilities available. So it may be possible that in the first group boy is selected, second group also boy is selected, third group girls is selected, or in first group boys is selected, in second group girls is selected, in third group boys is selected. Or it may be also possible from first group girls is selected and second or third group boys is selected. So the very first, the selection of boy 13 upon 32 is to answer, we are to calculate 13 upon 32. For getting boy, that is 1 upon 4, and getting girl, that is 3 upon 4. 2 upon 4, girl also 2 upon 4. 3 upon 4, 1 upon 4. So the first boy from first group 1 by 4. This is the probability of boy. Boy is 1 divided by total number of event is 4. Girl, the favorable event is 3 and total number is 4. So first group from boy, second group from second boy, and third girl 1 by 4. Boy from first group 1 by 4, girl from second group 2 by 4, and boy from third group, that is 3 by 4. Girl from first group, that is 3 by 4. Boy from second group, that is 2 by 4. And boy from third group, that is 3 by 4. So we will having 4 4 ja 16, 16 4 ja 64. That will be 2 plus 6 plus 9 2 ja 18. So that is 26 upon 64. So there will be 13 upon 32. That was to prove. So if in this manner the question is over there, here we was to prove that the probability of 2 boys and 1 girls is 13 divided by 32. So we have calculated 2 boy, 1 girl, 2 boy, 1 girl, and 2 boy, 1 girl. Okay. Now, if they ask that, now question change. Question is change, 2 girl, 1 boy. Second question, 2 girl, 1 boy. So it may be girl, girl, boy, girl, boy, girl, boy, girl, girl. Here 2 girls, 1 boy. First and second girls, third boys. First and third girls, second boys, and second and third girls, first boy. So here the girl is over there, that is 3 upon 4. Then 2 upon 4. Then boy, that is 3 upon 4. Okay. Now girl. Girl is 3 upon 4. Boy is 2 upon 4. And girl is 1 upon 4. Boy in first, that is 1 upon 4. 2 upon 4. 1 upon 4. This is the girl. First one girl. Second one girl. Third one boy. First one girl. Second one boy. Third one girl. First one boy. Second one girl. Third one girl. So that is 64. 9 2 ja 18 plus 6 plus 2. Here also the same value over there. So there will be 26 divided by 64. So the probability of the girls also, probability for 2 boy 1 girl is 13 upon 32, and probability for 2 girl and 1 boy also 13 upon 32. Okay. Next one. From each group, one children is selected. Get the probability of at least 1 boy. Okay. At least 1 boy. That is 1 minus no boy in first, no boy in second, no boy in third. So that will be in first no boy, so 3 upon 4. In second no boy, 2 upon 4. And third no boy, 1 upon 4. So that will be 1 minus 6 upon 64. So that will be 64 minus 6 upon 64. (58 upon 64). At least 1 boy. The probability of at least 1 boy is 58 upon 64, because the probability of girls from first, it means no boy. Probability of girls from second, probability of girls from third. We are having 1 minus girls, girls, girls. From first group girls, from second group also girls, and third group also girls. If we want probability of at least 1 girl, there also we are having same situation. At least 1 girls, it means 1 minus boys in first, second, boys in second, and boys in third. So 1 minus the probability of boys in first, 1 by 4, the probability of boy in second, and probability of boy in third. So that also 1 minus 6 upon 64. So that is 64 minus 6 upon 64. That is also 58 upon 64. So in this manner, in probability, if any type of the question is over there, if we will go what question is asking, certainly you can solve the question. So I have given so many examples related to this. We are having new one question. One more question we are having. A bag contains, one more question related to the probability. 6 white and 4 black ball. A bag contains 6 red ball and 4 green ball. One bag contains 6 red ball and 4 green ball. 4 ball taken one by one. What is the probability that will be having different color? Againly I am asking. You first listen what the question is asking. It's very important. You should learn the language of the question, then you can solve the probability, otherwise you cannot solve the probability. One bag contains 6 red ball and 4 green ball. 4 ball taken one by one without replacement. What is the probability that they will be having different color? It means first time red, then green, then red, then green. Okay. So one by one is taken. So it may be possible starting from red. So red, green, red, green. Or it may be possible first is green, second is red, third is green, fourth is red. It may be, firstly we are starting from the red ball. So the first is red, second may be green, third may be red, fourth may be green. Or it may be also possible. So the probability is the addition of the all possibility. So it may be also possible the first is green, second is red, third is green, fourth is red. So getting first red, that is 6 upon 10. Then green 4 upon 9. Now red is, one red have come out. So now red is 5 and total is 8. One green come out, so total green is 3 and total ball is 7. Okay. We started from the red ball. So red ball, then green ball, then red ball, then green ball. This is without replacement is over there. So the first the total number of ball was 10, then 9, then 8, then 7. Now starting from the green, first is green ball 4 upon 10, second is red ball 6 upon 9, third is green ball is 4, now 3, and red ball is now 6 to 5. So this, okay. Now we are solving this. 4 2 ja 8, 3 3 ja 9, 3 6 ja, okay, 5 2 ja 10. So 1 upon 14 here. Here also we are having 3 3 ja 9, okay, 4 2 ja 8, 3 2 ja 6, 5 2 ja 10. So 1 upon 14. So 2 upon 14. So answer will be 1 upon 7. So if this type of the question is over there, then also you can solve. Just you have to keep in mind what the language of the question is over there. If you will go with the language of the question, certainly you are able to solve the question if any type of the question is over there. One more question related to the Bernoulli theorem. In a binomial distribution based on Bernoulli theorem consists n is 5. In a binomial distribution based on Bernoulli theorem consisting 5 independent trials, probability of 1 success and 2 success. Probability of 1 success is given 0.4096 and probability of 2 success is given 0.2048. So then calculate the value of P. This is third question. Againly I am repeating the question. Firstly understand the question. In a binomial distribution based on Bernoulli theorem, there are 5 independent events. The probability of occurring one event is 0.4096 and probability of occurrence of two is 0.2048. Then find the probability of P and Q. So NCR, Bernoulli theorem is NCR, P raised to power R, Q raised to power N minus R. So first one 5C1, P raised to power 1, Q raised to power 4, and this is given 0.4096, equation number first. And 5C2, P raised to power 2, Q raised to power 3 is given 0.2048, question number second. So by dividing first and second, 5pq4 that is 0.4096, 10p2q q3 that is 2048, number 8 and number second. So 1 divided by 2, equation 1 divided by 2. So 5pq4 divided by 10p2q3 that is 0.4096 divided by 0.2048, point to point cancel, this cancel 2 times. q3 cancel, so and p2 cancel, so here this is 2 times, so q upon 2p is equal to 2 upon 1. Here q, here p is available, so 5 2 is 10, 2p is equal to 2. So now q is equal to 4p, okay, q is equal to 4p, 1 minus p is equal to 4p, so 1 is equal to 4p plus p, so 5p is equal to 1, so the p value is 1 by 5. As we know, p plus q is equal to 1, so the q will be 1 minus p. So I have written value of q, that is 1 minus p. So the value of p is equal to 1 by 5. Firstly, what we have done, for 5 independent, probability of one occurrence is 0.4096, probability of two occurrence is 0.2048. So we have written 5c1 p1 q4 that is 4096, 5c2 p2 q3 that is 0.248. Solving pc1 is 5c1 and 5c2 value is 10. 5c2, 5 multiply 4 multiply 1 multiply 2, that is 10. p2 q3. Now equation number 1 divided by equation number 2 for comparison. So we are having q divided by 2p is 2 upon 2048, that is 2 times. So q is equal to 4p and putting the value 1 minus p, that is q, so 1 is equal to 5p and p is equal to 1. Okay, now we know the 1 p plus q is equal to 1. Now we have knowledge that p plus q is equal to 1. So 1 by 5 plus q is equal to 1. So q is equal to 1 minus 1 by 5. So the q is equal to 5 minus 1 upon 5. So the value of q is equal to 4 upon 5. We are to calculate the value of p and q. So we have calculated the value of p and q. So in this manner also, in examination, there may be a question of Bernoulli theorem in this pattern also. So you can solve this also. One more question, one more pattern for the Bernoulli theorem is over there. And this is the last question related to the Bernoulli theorem. Later we will have Bayes probability theory or mathematical expectation. One more question. This is question number 4 in Bernoulli theorem in today's video. An experiment succeeds twice as it fails. One times is fail and 2 times is success. So the ratio of success and fail, that is 2:1. Againly I am repeating the question. Question is this: an experiment succeeds twice as often it fail. What is the probability that in 5 trials there may be 3 success and at least 3 success? In 5 trials, the first there may be 3 success, at least 3. The question is this: an experiment fail after twice success. It means the experiments 2 times succeed and 1 time fail. Total experiment number of experiment is 5, we are to calculate the probability of 3 success and at least 3 success, or at least 1 success. At least 1 success. Okay. So the probability is 2 by 3 and Q is 1 by 3, N is equal to 5 and R is equal to 3. First one is this. So Bernoulli theorem, this NCR P raised to power R Q raised to power N minus R. So that will be 5C3 P raised to power 3 Q raised to power 3. So 5 multiply 4 multiply 1 multiply 2, 2 by 3 raised to power 3 and 1 by 3 raised to power 2. So 10 multiply 2 raised to power 3 multiply 1 divided by 3 raised to power 5. So that is 80 divided by 3 raised to power 243. 3 raised to 5. 243. So the first answer will be 80 upon 243. This is the probability of 3 success. Now second one is at least 3 success. This is the probability of 3 success. Now at least 3 success, it means there may be 3, there may be 4, there may be 5 success. So that will be 5C3 P raised to power 3 Q raised to power 2 plus 5C4 P raised to power 4 Q raised to power 1 plus 5C5 P raised to power 5 and Q raised to power 0. This is the probability of 3 success, this is the probability of 4 success, and this is the probability of 5 success. Because the question is at least 3. At least 3 success, it means 3 may be, 4 may be, or 5 may be. More than 5 is not possible because total number of trial is 5. So we are having 5 multiply 4, 1 multiply 2, 2 by 3 raised to power 3, 1 by 3 raised to power 2, plus 5 upon 1, 2 by 3 raised to power 4 and 1 by 3 raised to power 1. And this is 1, 2 by 3 raised to power 5 and 1 by 3 raised to power 0. So that is 10 multiply 2 raised to power 3 multiply 1 upon 3 raised to power 5 plus 5 multiply 2 raised to power 4 multiply 1 upon 3 raised to power 5 plus 1 multiply 2 raised to power 5 multiply 1 upon 3 raised to power 5. So 243 3 raised to power 5. First one is 80. Second one 16 multiply 5. That is also 80. And third is 32. 2 raised to power 5. 80 plus 80 plus 32. So that is 192 upon 243. So there will be the value of 192 divided by 243. The answer is okay, 64 upon 81. So there will be 64 upon 81 cutting with having with 3, 3 6 is 18, 3 4 is 12, 3 8 is 24, 3 1 is 3. Now last question, at least one success. At least one success. So the very first we will calculate the value of 0 success. So 5C0 P raised to power 0 Q raised to power 5. So that is 1 multiply 2 by 3 raised to power 0 multiply 1 by 3 raised to power 5. So the value of 1 upon 243. At least one success. 1 minus probability of 0 success. So 1 minus 1 upon 243, that is 242 divided by 243 minus 1 upon 243. So answer will be 242 divided by 243. So in this manner, you can solve the Bernoulli theorem if any kind of the question related to the probability is over there. With the help of the Bernoulli theorem, you can solve which is question have impact of the Bernoulli theorem. So I think this video will be helpful for you to learn how to solve Bernoulli theorem. In our next video, we will having a Newman theorem of the probability. Thank you.